The second video for this week focuses on scientific notation from the Lesson 4.4 guided notes. This is probably a lesson that's going to be new for you, but it's a relatively short lesson, and if you pay attention to the directions, it's also, I think, relatively easy. So standard form is the way we typically write numbers. That's when we write numbers without those numbers containing exponents. So we can write a number as 5 million, or we could write it as 0.00000086. We can write it as 600, 6/10. That's standard form. That's the way we typically see numbers written. Scientific notation, though, is a way to write very large or very small numbers. And a number, the way we write this, it's expressed as a product of a factor and a power of 10. Why do we have scientific notation? Well, again, we're using this for very large and very small numbers. So we're using it in cases where it's pretty cumbersome to write out a really big number, whether it's a really large number, it's a really small number, so we can write it in scientific notation. This isn't always super useful if we have like a number, let's say 5,282,156, because you would then have to approximate that. But if you have a number like 15 billion, you could write that in scientific notation. Now, luckily, we can say it or write it as 15 billion. So we do have a shorter way. It's a little harder when we talk about really tiny numbers, which are used a lot of times in science, which is why we call this scientific notation. And it's a way to prevent us from making mistakes by eliminating a zero or adding an extra zero in a number. It's definitely important when people who are working with these really big or really small numbers, like someone working in the financial or banking industry, or someone working in the medical research industry, when they're working with these numbers, that they're accurate. So scientific notation is one option. It's probably not the most important lesson we're going to talk about here this year, but it is something that you may see in real life at some point. Scientific notation is written in this form. I'm going to highlight it in green. A times 10 to the nth power. Now this is really important that n has to be an integer. It can be positive or it can be negative or zero, but typically we're just talking about writing it with either a positive or a negative exponent. And then this value a has to be greater than or equal to 1 and less than 10. That's going to be really important if we're writing a number in scientific notation. So the first thing we're going to talk about is writing numbers in standard form. So here's our steps, and then we'll do some examples. You're going to move the decimal point the number of places indicated by the exponent. If the exponent is negative, you will move the decimal point to the left because it's going to be a tiny number. If the exponent is positive, you're going to move the decimal point to the right because it's going to be a bigger number. So why does this work? Well, this works because if we have something like 4.3 times 10 to the fourth power, 10 to the fourth power is 10 times 10 times 10 times 10, which is 10,000. So if I take 4.3 and multiply it by 10,000, that's going to get me 43,000. But again, a way we could do this is just take the decimal point in 4.3, move it to the right 4 places. So we'll move it to the right 1, and then an additional 3 places for a total of 4 will get us 43,000. What if we have something like 5.2 times 10 to the negative second power? Well, remember that 10 to the negative second power is 1 over 10 squared, or 1/100th. So it's like taking 5.2 times 1/100th, which is 5.2 over 100. That's the same as 52 out of 1,000, which is 0.052. Again, another option you have is just take the decimal point, move it to the left 2 places. To the left because of the negative exponent, and 2 places because the exponent is a 2. So let's do some examples of writing numbers in standard form from scientific notation. So I'm going to go down along this left-hand side. It goes on the second page of your guided notes as well. The number 1 is 3.78 times 10 to the 6th power. Because it's a positive exponent, I'm going to move the decimal point to the right, and I'm going to move it 6 places. So you can see these little like loops that I made here. So I went 1, 2 to get past the 8, and then we need another 4 places to get a total of 6 places to the right. So in these little humps or waves that we have here, we're going to add zeros. So we add 4 zeros. So we have 378 with 4 zeros. I do always like to add those commas in so that we can see what the number is. It's 3,780,000. Without the commas in there, it's kind of hard to read the number. So it's kind of a good idea to put those in so you know how to read it. I did want to mention one of the mistakes students make a lot is they see the 6 exponent and they're like, oh, I have to add 6 zeros. But in this case, you only need to add 4 because there's 2 numbers after the decimal point that are included as part of the 6. All right, number 2, we've got 5.1 times 10 to the negative 5th power. So this time I'm going to move the decimal point to the left 5 places. So 1 place to the left gets me past the 5. And then we need to go 4 more places. And I'm going to move my decimal point right here. You're going to notice up here I didn't put the decimal point at the end of the number, but we do need it here at the beginning if we have numbers after the decimal point. So our answer is going to be 0.000051. We could figure out what that is in terms of place value. That's a little trickier. No commas here, though, for these tiny numbers. Sometimes students want to put those in. You do not need them for these tiny numbers. Make sure when you're putting your comma in, though, or commas in, it's every 3 starting at the end of the number. So sometimes I have students who start at the beginning and they put the commas like here and then have this random 0 at the end. You want to start at the end of the number and go towards the left. These are just common mistakes I see students make. So number 3, we have 6.81 times 10 to the 7th. Positive exponent means I'm going to move the decimal point to the right 7 places. So 2 places to get us past the 1, and then we need 5 more places, so 5 zeros there. So let's add our commas in. We're going to get 68,100,000. Feel free at any point to pause the video, try some of these on your own if you feel comfortable. There's quite a few here. Number 4, 2.74 times 10 to the negative 3rd power. Negative exponent means I'm going to move it to the left. So 1, 2, 3 places to get 0.00274. Number 5, I'm also going to move the decimal point to the left because it's a negative exponent, but only to the left 1 place. So that's going to get us 0.81. Now you'll notice I have the 0 that's in front of the decimal point. It's not required, but I do still like to include it. Number 6, 4.8 times 10 to the 1st power. Move the decimal point to the right this time. So that'll get us 48, because really all we're doing is taking 4.8 times 10, which is 48. Finally, number 7, 1.28 times 10 to the 10th power. Move that decimal point to the right 10 places. So 1, 2. Now we need to go 8 more places. So this number, when we add our commas in here, let's see, we're in the thousands, millions, billions, 12,800,000,000. One thing I do want to mention, you might have seen scientific notation at some point in your calculator. It might show up as times 10 to some power. Some calculators will just have little numbers in the top right-hand corner. You may have even accidentally put your calculator in a different mode, which is the scientific notation mode. So you might have seen this before, just kind of playing around with your calculator. I do expect you to be able to do this lesson without a calculator, though, because yes, you could type in 3.78 times 10 to the 6th power, and it probably will give you this number. You just need to be able to move the decimal point left and right. It's nothing super difficult. Now, let's take numbers that are in standard form and write them in scientific notation. So what you're going to do is move the decimal point to the left or the right until you get a number greater than or equal to 1 and less than 10. That's really important. The number of places you move the decimal point will be your exponent. If you moved it left, the exponent will be positive because that meant you had a big number. If you move the decimal point to the right, the exponent will be negative because it meant you had a small number, like a 0.00 kind of number. So let's start with 60 million here, and you're going to notice how I set this up. So I moved the decimal point from the end of the number to the left until I found a number between 1 and 10. So if I move it just, let's say, 1 place to the left, this number is still too big. 2, 3, 4, 5, 6. Right now, if I imagine covering up all these zeros, I've got the number 60. That's greater than 10, so I've got to keep moving it. Now I've got 6, 6.0 or whatever you want to call it, but it's still 6. 6 is between 1 and 10. Now, if you go one more place to the left, you get 0.6. Why doesn't that work? Well, 0.6 is less than 1. So again, it's a fine balance here. You need to get exactly the right spot. We're going to get 6, and we moved it 3, 6, 7 places. So this is going to be 6 times 10 to the 7th power. You're going to notice we typically use the x for multiplication here. That's just the format you typically see. If you use the dot, it's not wrong. It's just the way we show scientific notation. Number 9, we've got 0.000085. So we're going to move the decimal point to the right this time until we get a number between 1 and 10. Again, be careful. If I stop here, I'm going to get 0.85, which is not between 1 and 10. One more place to the right will get me 8.5, and I moved it 1, 2, 3, 4, 5 places. So we're going to get 8.5. Again, this is the number that needs to be between 1 and 10 times 10 to the negative 5th power. Next number is 55,000. We're going to move the decimal point to the left this time until we get 5.5, which is between 1 and 10. We moved it to the left 4 times, so 5.5 times 10 to the 4th power. And again, it's a positive exponent because it's a bigger number, even though 55,000 isn't huge. Our next number is 520 billion. So we move the decimal point to the left here until we get 5.2. Remember, 0.52 is too small, 52 is too big, so 5.2 it is. And we move the decimal point 3, 6, 9, 10, 11 places, so it'll be 5.2 times 10 to the 11th power. Our next decimal, I'm not even going to try to read that, I'll end up missing a 0 here, but we're going to move it to the right until we get the number 2, not 0.2, that's too small. 2 is just right. It's kind of like Goldilocks here. And we moved it 1, 2, 3, 4, 5, 6, 7 places. So we'll get 2 or 2.0 times 10 to the negative 7th power. Number 13, we have 42,300,000. So for this one, we're going to move the decimal point to the left until we get 4.23. So we went 3, 6, 7 places, 4.23. And I don't round that. I'm going to keep those numbers there, times 10 to the 7th power. Finally, we have 0.00284. We're going to move the decimal point to the right this time until we get 2.84. Remember, 0.284 too small, 28.4 too big. We moved it 3 places, so it'll be 2.84 times 10 to the negative 3rd power. I know I'm going through this quickly. Feel free, again, as you're working through the practice on this, to go back to these guided notes and look at them again. Look at the examples. Remind yourself how to do this. Our last few here are just ordering numbers from least to greatest. What I did was I actually wrote them out as numbers instead of being in scientific notation. You can compare them without doing this. So in number 15, let's take a look at these. So 4.9 times 10 to the 4th is 49,000. 9.9 times 10 to the negative 4th is 0.00099. And 5.6 times 10 to the 4th is 56,000. You don't have to write them in standard form to compare them. Obviously, this guy right here has to be the smallest because it's got a negative exponent. And then if you want to compare these two guys, they have the same exponent, and 5.6 is bigger than 4.9. So this would be my next smallest, followed by this guy. But another option is to write them in standard form. So least to greatest will be 9.9 times 10 to the negative 4th, 4.9 times 10 to the 4th, and then 5.6 times 10 to the 4th. Number 16, comparing these, obviously our biggest is going to be this guy here since it has a positive exponent. Compare your factors for these two since they have the same negative exponent. And I know that 2.005 is smaller than 2.5. So this guy is going to be my smallest, followed by the 2.5 times 10 to the negative 2nd, followed by my 2004, which is 2.004 times 10 to the 3rd. Again, you don't have to write them in standard form. But again, this guy's my smallest, this guy's in the middle, and then the one with the positive exponent is our biggest. So number 17, I do think it does help to write them in standard form. 3.2 times 10 squared is 320. 700 is already in standard form. And 4.1 times 10 to the 2nd is 410. So least to greatest here, obviously the 3.2 times 10 to the second, followed by 4.1 times 10 to the second, followed by 700. It is helpful if they're not all in scientific notation to put them in the same form, whether it's scientific notation or standard form, that's up to you. Number 18. So for this one, 0.002, I left, sorry, in standard form. 3.6 times 10 to the negative fourth is 0.00036, and 2.1 times 10 to the negative third is going to be 0.0021. So if you want to write this guy in scientific notation, it would be 2 times 10 to the negative third power. So when we look at the smallest, 3.6 times 10 to the negative fourth is definitely the smallest because we're going to have more zeros in front of our numbers. And then this guy is going to come next since 2 is going to be smaller than 2.1. We've got 0.0020, and then this one is going to be 0.0021. So this guy is going to be our biggest, this guy is going to be in the middle, and then this guy right here is going to be the smallest. So it does help sometimes putting them in standard form, just comparing place value. Clearly the smallest. I've got 0.002, 0.002. This one has a 1, which makes it bigger. This one does not, which makes it smaller. So just comparing those. I might put maybe 1 or 2 of these on the practice sheet for you to do, but really most of it is just going to be converting between scientific notation and standard form. And again, this is like some of our last topics because what we're seeing is new. If you feel a little uncertain, that's to be expected, and that's okay with these. So please try not to panic too much. These are things that you may see in the future as well. So you'll review them again, kind of like you see fractions year after year after year. Some of these topics you'll see again. So I did want to give you a chance to try some independent practice. Pause the video at this point and try these 8 questions. All right, hopefully you've taken some time to pause the video and try these 8. Let's go over the first 4, asking you to write these numbers in standard form. So taking a look at the first problem, we're going to move the decimal point to the right 8 places. So you should have a total of 7 zeros here. So you get 480 million. Number 2, move the decimal point to the left 3 places. It's going to get us 0.0038. Number 3, move the decimal point to the left 5 places. You're going to have 4 zeros followed by 295. And then for number 4, move the decimal point to the right 4 places. So you should have 2 zeros at the end to give us 16,500. Now, writing in scientific notation. Surprisingly, this is where students struggle a bit more. For number 5, move it to the right 4 places to get 5.2 times 10 to the negative 4th power. For number 6, move it to the left 6 places to get 1.2 times 10 to the 6th power. For number 7, we're going to move it to the left 5 places to get 1.45 times 10 to the 5th power. And for number 8, we're going to move it to the right 2 places to get 9.8 times 10 to the negative 2nd power. Again, don't forget this factor needs to be greater than or equal to 1 and less than 10. That's really important for us. All right, at this point, if you want to try assignment 1, you can do that. The next thing we're going to talk about is square roots, cube roots. Again, talking about squaring and cubing numbers again. That will be what your second assignment will be on. Thanks for listening.